Hi Year 12s, welcome to our first flipped learning video for this year for Stage 2 Chemistry. We have focused on topic 1, which is monitoring the environment, and it contains multiple subunits, global warming and climate change, which we've already gone through in class, and 1.2 photochemical smog, 1.3 volumetric analysis, 1.4 chromatography, and 1.5 atomic spectrometry. So our learning intentions for this PowerPoint slides are that we need to describe and write equations about how catalytic converters can reduce the quantities of nitrogen oxides generated by our motor vehicles. So this is their role. This is the reason why they were designed, to reduce these nitrogen oxides that are being released into our atmosphere. And we know that they're a greenhouse gas, and they can also contribute to things like our acid rain. So you'll be able to describe how catalytic converters work. This is your goal. And this is through the description, using words, but also through written equations that support the description of how catalytic converters can reduce nitrogen oxides being generated and released into our atmosphere. So you'll be able to write equations demonstrating the function of catalytic converters. So this is a catalytic converter. It kind of looks like this long elongated part that sits just before our exhaust pipe in our vehicles, and it was introduced into the exhaust system of motor vehicles to reduce the impact of pollutants, which are reduced through the exhaust system. So under certain conditions, catalytic converters are able to convert a number of products, or what we call precursors, of compounds which are involved in the photochemical smog process, and therefore it will lessen the harmful products and also environmental effects that happen through the release of these compounds. So this is its role, to reduce some of these compounds so they're not in our atmosphere, to contribute to photochemical smog. So there's different types of catalytic converters. The most common one is a three-way catalytic converter, and it typically consists of porous ceramic blocks. So when we talk about something being porous, what I mean by that is it has holes. So if something's porous like pumice, it often has holes, large surface areas, and often has lower densities. So they have channels which are long in length that allow the flow of emissions to travel through these porous areas. So coated with a thin layer of highly porous alumina or aluminum oxide with very small amounts of precious platinum group metals like platinum, palladium, rhodium, they're bonded to the surface of this alumina coating. So not only they're porous, but they have this coating of these metals, platinum, palladium, and rhodium, which are really important for the process that catalytic converters use and the chemical process behind them. So we can see the shape of the catalytic converters here. Again, we have this porous structure like honeycomb. We have our hydrocarbons that are expelled through the burning of combustion of our fuels from our motor. And we also have carbon monoxide, so one carbon molecule attached to an oxygen, and nitrogen oxides, which is NOx. Okay, and this could be their NO for nitric oxide. They could be NO2. The X just means the number of oxygens. So this is abbreviation of what we call nitric oxides, as a category of multiple different versions of nitrogen oxides presence. So water comes out the other side, so it flows in, water comes out, carbon dioxide comes out, and nitrogen comes out. So we know that water is present naturally in our environment, same from carbon dioxide, which is usually not from anthropogenic sources, and nitrogen is our highest gas present in the atmosphere. So what's coming out is all the things that are usually within our atmosphere, not things like unburnt hydrocarbons, carbon monoxide, which is really harmful for you, and nitrogen oxides. So the function of catalytic converters is through the oxidation process. So at the end of last year, we really started to touch upon oxidation and reduction reactions, and this is a version of it. So when we talk about oxidation, oxidation is the loss of electrons. It's also the gain of a hydrogen to oxygen bond when we're talking about organic chemistry. But then it's also, oxidation is often the gain of oxygen. So what we're seeing here is we start off with carbon monoxide. It has 2 oxygens present here. And then we have this carbon monoxide binding oxygen in the atmosphere to form 2 molecules of carbon dioxide. So in total we have 4 molecules of oxygen, because it's 2 times 2 gives us 4. So we've actually increased the amount of oxygen in this molecule. So this is oxidation. And again, we have carbon monoxide. We have a half a molecule of oxygen to form 2 carbon dioxide molecules. So we don't often write these things here as half fractions. You may see sometimes in combustion we do this because it shows that if we were to divide the molecule, it would be half of the molecules present. Okay, so combustion of unburnt hydrocarbons, we can see here there was 2 molecules at 25, or half of that. We do 25 over 2 because if not, it will be decimal point. So that's what it's just saying. So for every 1 molecule, there is half of 25 molecules of carbon dioxide, and then we have 16 carbon dioxide molecules produced and 18 produced as well. So our reduction can actually happen as well in this process of catalytic converters, where carbon monoxide and things like nitric oxide can react together to form our other product, which is the ones that came out the end, which was our diatomic nitrogen molecule and carbon dioxide as the products. And we can see that here we initially started with oxygen bound to nitrogen, and we know reduction is gain of electrons, it's also loss of oxygen, and it's also a gain of a hydrogen potentially in organic chem. So how have we helped reduce the production of primary pollutants? Well, the use of converters greatly reduce the quantities of carbon monoxide. That's really bad for us. If we breathe it in, we can die because it has a great affinity to our hemoglobin and makes us suffocate. Nitrogen oxides, which are those NOx molecules like nitric oxide and nitrogen dioxide, and hydrocarbons that are released into our atmosphere. And these things are really bad because they contribute to photochemical smog. So to work effectively, unleaded petrol, which is tetraethyl lead poisons, have catalysts. So the optimal temperatures, which are in the catalytic converter, may reach really high temperatures during a short journey. That's why we often see kind of gas coming out the outside at the back of our exhaust, is because at that portion it's very, very hot. So to reduce emissions by 90%, but it does increase the concentration of carbon dioxide, because we know water, carbon dioxide and diatomic nitrogen are the products. So even though we're not getting carbon monoxide, nitric oxides and some of these unburnt hydrocarbons, we're still increasing the proportion of carbon dioxide released and emitted into our atmosphere. So catalytic converters, this is really the science behind it here. We have hydrogen, carbon monoxide, nitric oxides going in, so some of these fuels, and carbon monoxide, nitrogen, goes straight through this porous honeycomb structure, which is coated in these rare earth metals. And we have water, carbon dioxide, nitric oxide coming out the other side. Okay, and there is processes and equations that we can use up here to show the process of what's occurring in our catalytic converters. The process of oxidation occurring and the process of reduction occurring through the movement of oxygen through here and the movement of electrons through this process. So we're going to describe and write equations showing how catalytic converters reduce quantities of nitric oxides generated by motor vehicles. We can also write equations demonstrating the function of catalytic converters and describe how they work. So the fact that they have porous structure, what goes in, what comes out, what they're coated in and why they're coated in them is really important. Okay, thank you.